Okay, hey everyone. FizzBuzz, congrats on the first. Hope you're doing well. Okay. I think we're gonna get right back into mechanics. I don't think I have anything pending in the Discord to work on. I was feeling energetic this morning and actually got back to some people in the Discord before I started the stream, which maybe, that's now one less thing to do on the stream, but, you know. Hey, Cook. Alright, so I ended on 7 last time, so let's drag in the next set of questions. Wait, I did go... Okay, yeah, I went live on YouTube. Alright. Okay. Why am I on 203% zoom? That's such a weird... Oh, I'm not... I'm somehow on 203% zoom, and that's not a round number, so I hate it. Oh no, this doesn't fit. Ugh. I hate that even more. Alright, new page. Digital pages don't just grow on trees. Oh wait, isn't there... Which one is zoom to fit? Okay, well I guess the zoom to fit is just 203. Alright. I already feel like... I still feel the caffeine high from my last coffee, but I made a second cup today, and I feel like it's going to be a bad idea, but I'm doing it. Hey Sark, did I listen to any Kanye West albums? I've heard some Kanye West songs. I never gone away to listen to an album. If you stand at rest on a bench, not just sit at rest, but stand at rest. The bench exerts a normal force on you equal and opposite to your weight. Which force is related to this normal force by Newton's third law? Wait. That's every action has an equal and opposite reaction? Okay. I've never been that into Kanye, Stark. Now, well, it theoretically should be the gravitational force from the Earth on me. Or is it the normal force from me onto the bench? Oh my god. Or none of the above. I definitely... I'm throwing out B. I think. Gravitational... You stand at rest on a bench. The bench exerts a normal force on you equal and opposite to your weight. Force is related to this normal force by Newton's third law. Let me read again about what they say about the normal force, because I assume there's an important distinction here. I don't see why it's important right now, but... No, yeah. That's funny. We do use the phrase throwing out to mean two different things, don't we? But yeah, no, I'm removing that. Okay, it's resisting being compressed. So if you stand the bench, so the free body diagram is of me. That's how I'm thinking about this. So the bench is exerting a normal force directly up, and since I'm at rest, gravity is equal and opposite. Well, I guess the distinction is this gravity or normal force? I think it's gravity. Like that's my first instinct with this question, but I usually my first instinct is wrong when it comes to Morin, so I think it's A. I don't know. What could it be if not A? Like, well, I guess it could be none of the above, or it could be the normal force of me on the bench, but 1 plus 2? I assume 3, but each body gets a dot. A dot for me and a dot for the bench. Okay. I mean, I don't quite know what subscript to put for the me for the downward force. That's the question, I guess. Taking notes, yeah. Bench. So the bench is also being pulled down by gravity and me. F me. Dude, F me when I do these mechanics questions. It's C? Oh, you have a big delay. Do you know any Lagrangian mechanics? I was thinking if you could help me get the equations of motions for a double pendulum. Ooh. I did a tiny bit of weird systems like that in my applied math class. I bet that Dr. Cooker Fizzbuzz would have a better like resource for you to look at. I could maybe try with that, but it's gonna I probably wouldn't be able to figure it out. Machine learning content for an online education platform? That's awesome. So why is that a normal force from me on the... Wait, what? A normal force from me to the bench. The bench is resisting being compressed by me. So it's like... Interview for a job in San Diego. Ooh. It's not a bad place to be, if you don't mind the heat. Yeah, if that's like some like differential, like is that going to be like a system of two differential equations? I might be able to like wrap my head around it, but I don't add any stream delay now. My stream, like when I watch people's streams, I do sometimes like get out of sync and have to refresh it or pause and unpause. But I don't have any stream delay on now. Just to get into a differential equation, then to approximate. And a double pendulum, I assume, is like string, ball, and then another string, ball, and the same line. Okay, yeah. You would do the approximation? Okay. Wow, that's a that's a thing right there. Oh, nice. That looks like what you probably want. Okay, yeah. There's a few too many L's and thetas in here for me to want to look at it more right now, but okay. Yeah, that seems like a pretty good start there. Math course, we're doing presentations. My friend is doing chaos theory. We're writing him a simulation for it. Ooh, that's sick. I feel like Zach has mentioned looking a little bit into chaos theory. I don't know that he knows that much about it though. Now that I think about it, but it's about that trick or second order differential equations. Okay. Oh, nice, Fizzbuzz. Thank you both for getting those resources. All right, well, apparently the answer to A is C, but I still don't know why. The Lyapunov exponent. The Lyapunov stuff was some of my favorite stuff that I did in my degree. I don't think it was this though. It was a different Lyapunov thing. Yeah, no, okay. I forget what it was called, but it was a different thing with the Lyapunov's name. Wait, your friend is staying up until 8 a.m. in your time to look at the American election? That's crazy. That's true, yeah. As far as I know, it's very unlikely to be called in one person's favor today or tonight. But I don't really know that much. Oh, like the year two. Who knows what's gonna happen? I don't know. I'm just trying not to think about it. Yeah, there you go, Cook. I'm surprised hearing that from you, but that's my attitude right now. Yeah, I mean, there might be some. I know generally what happened in 2000. What I'm talking about is that states are going to be pretty slow to count votes. Like certain states are. Giga chat, exactly. um, what the hell is the free body diagram here? Like, I'm still experiencing a force due to gravity. The bench is only, it's holding me up, but it's not doing anything else. The hanging Giga chat. Oh my god. Okay, that was actually. Okay. In Pennsylvania's, is like they're not allowed to count the mail-in ballots until the day of today, so that's why they're expected to be slow. We syntax errors on the ticket, Cook. You didn't know? Hatsune Miku, there we go. Those are candidates I can get behind. The current Finnish presidents were on the bottom 30% of our version of the SAT math section. Dang. I mean, that's a funny stat, but like, it's not like the president's expected to do any calculations themselves. Like the job of any leader is to like listen to recommendations from like their staff and ideally have good judgment and choose the right recommendations. So I actually like, it's funny to hear that, but I wouldn't actually like mind that. I mean, that's fair, yeah. Okay, I guess I'm just gonna look at the answer because I seriously don't get why 8 is anything but A. I believe that, you know, I'm doing it wrong, but I don't get what's wrong. It is C. Well, what's confusing me is the terminology. Like, I feel like anytime it doesn't have a specific name, you just call it the normal force. That's what I don't really get. Uh, what I don't get is like, why is that called the normal force? Like, it feels like the normal force is just like the catch-all that you just kind of call whatever force that you don't have a different name for. Oh, it seriously means normal in that sense of the word normal? Oh my god. Hey, Phobos. Seriously? I guess that makes sense. Now that I think about it, like, okay. Well, I feel stupid. Um, oh, the argument with the Earth involves the second law, not the third law. Hmm. Yeah, I want to see Fizzbuzz's version. What am I looking? Wait, double pendulum zeros? Bluish areas are where the double pendulum is nearly periodic. This is not what I thought it would be. This looks sick. Like, aesthetically. I don't know how to interpret it, though. Well, I can read that. I don't know what all the other stuff means, but um, or like I assume there's like some shading happening with like if as it transitions from one color to the other, that means that something is happening. It's not the best. Okay, no worries. I get it. Clears are the rare ones. Oh, okay, fair enough. Hey, Rapture. How's it going? I'm doing good too. Thanks for asking. Okay, well, if I can ask a stupid question. I mean, okay, even okay, so like in figure 4.2, just even remove like the smaller block on top. If I'm just exerting a force onto a block and pushing it along, if there was an equal and opposite force in the other way, wouldn't the block not move? That's something that I never understood about Newton's third law. Like, I feel like that's like something that I'm missing there. Tried to use books from the Open Logic Project. I never heard of them, no. The third law pairs acts on different bodies. Go back to the Morin statement of it. I mean, so one of the bodies is me, the other body is the box. Right? Is the block. Okay. I said it was a stupid question. But I guess the thing that's weird about that is that I'm not moving if while I'm pushing the block along. But that's because I'm what using whatever like friction to like not move. The fish exerts force on the water exerts the same amount of force back on the fish, propelling the fish forward. That's kind of neat way to think about it. Yeah, but if we're not standing on ice, or if you're sitting on ice and I'm not, then I could push you and you'll move and I won't. In that case, the friction from the non-ice surface is exerting a net force on the you-me pair that is responsible for changing the net momentum. Okay. Yeah, I mean, I guess you'd be assuming that I'm standing like really like rigid or something, but well, I feel like I understand like perfectly well that if you're on ice that and you push off someone, you both like get pushed away. I just don't understand how it still holds in other situations. Because like for shit like 3 blocks all in a stack being pushed forward, like I don't know how you use it there. Like or like I like wasn't it important there? I honestly I Hey chaotic dude, how's it going? And you're both on ice, but there's a wall at my back. Okay. Assume you're in a functionally isolated system at the start of your statement. Yeah. Yeah, chaotic dude. I was doing some of these on my last stream and I was getting really annoyed. And I've gotten a couple of like problems down, but I'm still mechanics is just annoying. I need to like or I really want to like learn it though. If I push you and you move away, On the ice, your body does indeed still exert a Newton third pair law force on me. That okay. Okay. Then I think I'm okay then. As until it comes to applying it again. But so one of the big takeaways of Newton's third law is only ever talk about exactly two things. Not just one and not three, but two things. For now, or for this immediate question, I think I'm okay because Dr. Cook has been like explaining it, but I was just asking a really stupid question about Newton's third law. And so I think Cook has helped me through it. If they're, yes, consider all pairs, but only ever in pairs, I guess. Okay. I was taught physics in a way that you memorize the formula and you figure out which one you need to use for the question that you're looking at. This style of teaching from Morin is completely weird to me in physics, and I think that's a big part of why I find it so difficult. There's no like there's barely any like dimensional analysis. There was basically nothing about how to think about physics. For these box problems, you typically want to do two steps. One is to assume the sum as a whole, then consider forces on each individual box. Yeah, it's always tricky to actually apply it, but that is helpful. Territory. Have you gone to the center of mass? I think it'll be good for connecting all the concepts together. I've learned a little about center of mass in general, but I don't think we've talked about it yet. I assume that'll be a momentum thing. I'm not quite sure where the book does it. It's part of our midterm 1 mechanics last month, midterm 2 next week about momentum, energy, and rotational dynamics. Oh god, good luck. Calculus variation? No. I feel like it'd be a nice thing to know, but I've never studied it. Alright, number 9. Whichever the car steps on the gas, the car starts with acceleration A. When writing down the horizontal F equals ma equation for the car, the F acting on the car oh. Equal TF. Thank you so much. Welcome in, everyone. I gotta confess, I'm not familiar with the stream. Please, I'd love to hear about what you do. For you and anyone who's, or for anyone who's new here, I'm Don. I do math help streams. I also do some game streams, but right now I'm doing math. And while I wait to see if someone in chat has a question, I do some studying. So right now I'm looking at some physics. Oh, I can see Stuki and Joseph were over there. Well, thank you very much. I appreciate that. We're gonna do helicalculus variation, then we do general relativity. All right, I'm game for it. Equal TF. Hey, thank you very much. What were you doing? Essentially, one of my favorite theorems is Noether's theorem, named after Emmy Noether. Let's look that up. Oh my god. I certainly do not give political analysis. We don't need another dumbass on the internet giving their opinion. Let me follow you before I forget equal TF. Every continuous symmetry of the action of a physical system with conservative force has a corresponding conservation law. Oh. That feels very profound, but I feel like I need to know. Like I feel like I would need to see like examples of that. Introductory Lie algebra stuff for physics. Greatest Chris and Stuki. Well, thank you so much for suggesting me, Stuki. That's awesome. Always happy to see another person doing math and physics stuff. It looks for symmetry in your system and you can find conserved quantities, so you can derive conservation of momentum and energy using math. That's awesome. Doing calculus, how many times I've heard that during the semester? Yeah, yeah. Whatever Wikipedia classifies as calculus, that thing comes up. Tirac, Euler-Lagrange equations have always been mysterious to me, even if I've seen the derivations. They're mysterious to me too, to be fair, but I also haven't seen the derivations. Thank you for the follow, equal TF. Oh yeah, Cook. Chaotic Dude is in he's definitely in Gold's Discord and he might be streaming soon. Okay. Formerly Algebra I learned a bit on my own. Tiratar, like you can convert a functional optimization problem into a differential equation. Oh, that's kind of awesome. For the Euler-Lagrange equations, yeah, I've only ever like looked at the Wikipedia page briefly, but I never actually tried to understand them. And Cook, Coyote was talking about doing something with quantum mechanics. It's about the same. Neat. Yeah. No, I feel bad. I just don't always know like what to say that or like what to say when people are talking about stuff that's way beyond me. Like I never don't mind people like talking about it, but I don't want to like ignore it. While the nerd density is high, you need to proselytize. Okay. Oh, it's you, Fizbuzz? Hey, better late than never. Is it a... It's a big link right there. All right. I'm looking at number 9 right now. I feel like this should be... Oh, is it? It should be friction. Because if the car wheel... Okay. This is how you draw a car, everyone. I know it looks like a frog right now, but that's because we haven't put the top on. Get a little buggy. It still looks like a frog with a hat, actually. um, Okay, so if the wheels are spinning, they have to be spinning that way around, right? Let me actually, let's do that in a different color. No, that's the wrong. Their wheels are spinning that way around in order to go forward. Right at that contact point, the wheel is trying to move that way, like tangentially, and so friction, I think, is going to push you forward. I think that's how this works, I hope. How many course everything you know about QM? Oh, that's sick. Because the normal force, it's normal, which means perpendicular. It's not just a weird name for a force. Okay, D is just right out. Energy? We're not talking about energy. Oh wait, we have two friction options though. Okay, I feel like you could propel a car forward if you stomp the gas hard enough. Like if you physically like did that, but I don't think we're talking about C. Griffith's QM is overrated. Ooh. Fighting words. As someone who's never studied QM. Okay, let me go put my mug away. Okay. Now, I feel like they're going to have some crazy justification for why it is E, but the book has a whole paragraph, or no, they have a whole section about how MA is not a force. And so unless I'm misreading this, I think it just has to be B. And I don't necessarily know what backwards, I guess backwards means like, no. I'm saying it's B. B! I did one right for once. Look at me go. Oh, I just spoiled myself on the next one. I shouldn't have tried to read the entire thing. Oh, the important part is justifying it. I was too much of an eager beaver. You must lurk. Sounds good, Fizzbuzz. Thanks for lurking. Oh, is the Lauren person here in chat right now? I just noticed that they DM'd me a problem. I'll take a look at this, but if you are watching, I'd rather people post math questions in my Discord, because if I used to let people DM me for math help, and then it basically became like a full-time tutoring job for free, and that it just got way out of hand. So I'll work on this one bit in the future. If you could please just like post in my Discord. What's happening with this limit here? Also, I'm not always good about checking my Discord while I'm on stream, or it's just not always possible because I have 2 chats to keep track of already, and it's like look at my Discord periodically. All right, so Dr. Focus column 0. How do you deal with infinity minus infinity? So yeah, the issue with this limit is that x goes to infinity, and then this thing inside the ln also goes to infinity, and ln infinity is still infinity, so you just kind of get infinity minus infinity. And that's no good. Oh, maybe... Oh, I think I know how to deal with it. So we have to look for some kind of like manipulation we can do to like change how this thing looks. Territar is saying to factor out an x. There might be something to that. I'm curious to try rewriting this x as ln of e to the x, because this is equal to x. Like, we haven't actually changed the value of this thing here. And the value in doing this is that we can use log identities, that ln of a over b is equal to ln a minus ln b. So we have the right side of this identity, so we could make it the left side. So it's this thing divided by this thing. And hopefully this is a limit that we can solve. Oh, yeah, that's true, Cook. That's a nice way of like eyeballing it, but I assume the person is in a math class and they don't usually like that in a normal math class. I think what I want to do is factor out an e to the x from the bottom. To do this like algebraically. And I want to cancel out the e to the x's here now. Okay, and this is what we want here, because the only thing that's going to infinity, or the only thing with x's now is the x divided by e to the x. And e to the x is an exponential function. That thing blows up really quick. Actually, we can even prove this in a separate thing. Well, so what we really have to like care about is the limit just as x goes to infinity of x over e to the x. Like this little bit here, that's the only thing that's really involving x's. And so just by eyeballing it, we know that the exponential functions blow up way faster than a linear function. And so a very big denominator means a very small number. And so intuitively, I think this thing should go to 0. But if you know L'Hopital's rule, we can show it mathematically. Hey, Gold, e to the x is supreme. Tetration is supreme. Just wait until you see x to the x. Yeah, even supremer. But yeah, I would use, if you actually show us, I would use L'Hopital. So we can take the derivative of the top and the derivative of the bottom. The x becomes 1, the e to the x stays the same. And now this, we have a constant 1 divided by something blowing up to infinity, so that's going to go to 0. X factorial to the x factorial, true. And why not x to the x to the x to the x at that rate? That's like, I don't know what that would be called. I guess that's still titration, isn't it? No, I don't know. I'm just doing shit. Anyway, the important thing is that this thing in here goes to 0. And so we get ln of 1 over 0 plus 1. That's just ln of 1, and that's equal to 0. So I'd say the limit should go to 0. I hope that makes sense, Lauren. Let me know if you have any questions on that. Might be good to put that in a little squiggly border because it's side work. Yeah, I'm thanks so much. Yeah, no worries, Lauren. I'm kind of glad that I thought about it because when I first saw the problem, I didn't realize that we could do that. Actually, I was just tutoring someone last night where we had to use this in an unexpected situation, so it was a little bit on my mind, I guess. Territar in the YouTube chat was saying to try factoring out an x, and I'm kind of curious to see if that can work. I don't know where we should factor the x out from. Maybe from inside the log? Oh, this might work too. Well, no, we still have infinity minus infinity, don't we? With those two bits. Back from voting, I wouldn't go for a run for a bit. We're streaming, nice. Oh, Territar wanted to factor the x out from the entire thing. Okay. And so the point is that you could do L'Hopital's on that fraction there. The x on the outside kind of makes me nervous. There probably is a way to make that work, though. It's not as clear to me where to go from here, though. Oh, I think Cook is just making fun. He's being a Giga Chat and being like, oh, what election? Voting? What's that? All right, that's a neat little limit. I'm glad that I could see myself really suffering over that limit and not seeing the trick. So I'm glad I managed to spot that one quick. All right, what's up with number 10? The static friction force between the car's tires, and I did get spoiled on this one, but I still want to justify it. The static friction between a car's tires and the ground can do all of the following except speed the car up, slow the car down, change the car's direction. Oh, I call that kinetic friction. Is it technically static friction when the tire is rotating? Oh, I guess I could see. Oh, okay, that's weird. It is static gold? Okay. I guess I can understand that when it's rotational. Kinetic is when it's slipping. Oh, okay. Oh my god, Cook. Ugh. Yeah, Territar, good catch. Um, okay, well this one's it just like static friction is the only thing that's really acting. Like I already know the answer is D, like, but I feel like this one I would have gotten. Like this feels like it's obvious. I don't know. Like what else could it possibly be if not static friction? You're running in 2028, going to be a new party called the Dance Party? Hell yeah. Sign me up. The bottom point is counterintuitively instantaneously at rest. Yeah, that makes sense. Now that, like, you guys say it. Yeah, I was like thinking about that. It's like, man, that feels so weird that the friction is pointing forward, but it's because it comes from the rotation, and so that's just what happens, I guess. Um, the friction points inwards. Oh yeah, because you need to be accelerating inward to move in a circle, and the friction is the thing that has to be doing that. I guess yeah, your wheels are like tilting to make that to point the friction the right way, I guess. Oh, come on. Friction opposes the direction something wants to go, not say where it is going. Okay. What is that, Cook? That looks like a sketchy link. Wendy Cepeda, can you please answer the slope topic? Like y1 minus y2? Yeah, sure, Wendy. Um, okay, so the slope, it's like you're measuring the steepness of the line. And a lot of times that's called rise over run. Hey, Bode. How's it going? So, intuitively, I'd say that if this is our normal x and y axes, the slope is measuring the steepness of the line. So zero slope is a completely flat line. So I'll do that in green. And we usually use the letter m to mean slope, so I'll say m equals 0 here for zero slope. And then maybe in blue, the other kind of like extreme case is a vertical line. And we don't really have a good thing to call that. You could say it's infinite slope, but that it's not too important. You don't usually have to care about that when you're first learning this. But the moral of the story is that the closer your slope is to 0, the flatter the line is. So if you have a line that's like nearly flat, but just a little bit up, kind of like that, that's like a pretty small slope. Whereas if you have a line that is really steep like that, that's a very high slope. Terrible. Oh, I'm sorry, Bode. Well, I hope whatever's happening that your day gets better. Okay, and so that's kind of intuitively what slope means, or like that's like visually how it looks. You could also think about it where, let's just draw a generic line like that. If I start here on the line, and usually think of x as our input. If I'm starting at say x equals 1, and I increase my input by 2, let's say, to like x equals 3, how much like of the output do I get for that input? That's another way of thinking about the slope. And so it's kind of like anytime you have like a rate, you could think of it as a slope, where like when you go to the grocery store and you buy an apple or something, you pay per the pound. So the total amount you spend on apples depends on how many pounds you buy. So like I'll say like pounds, maybe pounds is bad if you're not American, but pounds of apples. And this will be cost of apples up here. If the line is very steep, there's a very high price per pound. That's kind of like I'm starting with this kind of like visual explanation because that's how I think about slope personally, but now I'll get into the actual like calculation stuff. It's kind of dumb, but I'm big football/soccer fan. Never gets to miss a game. It's 7 years. I'm 17 now. So I see my team lose by 4 goals in 4 years. That's not dumb. With all the things that we're invested in. Doing the Penn Center mistake of jumping straight into nightmare mode mechanics. True. Okay, so the formula for slope that we know and probably don't love is m equals y2 minus y1 over x2 minus x1. And the top, or like the bottom, is the change in x. That's the thing that we talked about with going from x equals 1 to x equals 3. And the y2 minus y1 is the change in y. That's like the output, how much you're getting out vertically. And so if you're given, I'll just do an example. If you're given 2 points, let's say 1, 2 and -3, 5, we can find the slope of the line connecting those 2 points by plugging into the formula. It is important to be consistent with what's y1 and what's x2 and y2. It's a very common mistake to mix up the ones and twos. So I'm going to write what's what over here. Y2. Okay, so, and this is arbitrary. You could also flip which one is 1 and which one is 2. You get the exact same answer. So you can choose whichever one you want to be 1, whichever the other one to be 2. So y2 we said is 5 minus the other y value, 2. And now we go back over here to -3 minus 1. And so as long as these two are a point and these two are the other point, you're fine. Now you just do that math. So on top we get 3, on the bottom we get -4. And so we can make the negative sign just come to the middle to be -3/4. They'll probably also ask you a question. They'll probably give you a graph and ask you to find the slope of that line. So let's do that. And when if you have a specific question at any point, please do let me know. But if I don't see one, I'm just going to ramble. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. Okay, if they give you a line, let's say I want to connect that point and that point in a line. Let's see how good at drawing I am. Okay. So if I have a question where they give you a graph and ask you to find the slope, you wouldn't devastate if you went, your mom almost bought tickets. Oh, geez. If you're just given a graph, just look for any 2 points on the line. You can definitely tell where they are. So in this case, I'm going to do this point here, which is 0, 1, and this point up here, 2, 4. And now you can use the same formula here. You can also kind of count from one to the other. So we're changing in y's. We're going from 1 up to 3 vertically. Or I'm sorry, from 1 to 4. And so that difference is 3. And then horizontally, we're going from 0 to 2. So that's 2. So you know the slope is 3 divided by 2. So yeah, maybe I'll end with one point, or like one last point, unless you say something, which is I've only shown examples of positive slopes. Positive slopes go up and to the right or down and to the left. It's just, same thing. You can also have a negative slope, which is just like mirrored, I guess. So like that's an example of a negative slope. It goes down into the into the right. Are the y2, y1, x2, x1 formula and y1 formula interchangeable? Yes, they're basically the exact same thing. Like the y2, y1, x2, x1 formula, it is rise over run. They're talking about the same thing. Like the y's are the rise, the x's are the runs. And they say rise because you go like, you're really like rising on the graph from one point to the other point. Like that's rise. And then the run is the other direction, like that's run. So two different ways of saying the same thing. Can both be used in all slope cases, or are there any exceptions? Anytime you have a line, you can always use these. Yeah. They could ask you about like a perpendicular line or something like that, but like anytime if they're asking, if the question is simple or just asking about a line, then this is always good. Jose, you want to find a derivative? Yeah, sure. We can look at that in just a second. You too, Wendy. Okay, so let's look at Jose's question. Wait, never mind. Okay. Your call. Sheet. Let's just delete this page. If you do end up having a question, let me know. Then I'm just going to go back to my setting. A car is traveling forward along a road. The driver wants to arrange for the car's acceleration to point diagonally backward and leftward. All right. Well, we have a very rectangular car. It's that, is it the Cybertruck that looks like that? I don't know. But it's moving forward with velocity v. We want the car's acceleration to point diagonally back and left. Is this not turning left and braking? Because if velocity is forward and the acceleration, like this is like pulling into a parking spot, I guess. So yeah, you'd want to slow down, and I don't know, like it should be turning left. That feels too simple though. It's usually more complicated. Let's check the answer. It is D. Okay. Oh, Cook, you were wrong. Ooh. Yeah, yeah. I don't really know what the purpose of the question is, to be honest, but I apparently did it right. Blocks that rest on a plane inclined at angle theta. Forces on it are gravitational, normal, and friction forces, as shown in figure 4.6. These are not drawn to scale. The following statement is true is always true for any theta. Wait, Territar, braking left will create a component of acceleration going right? I don't think so. I don't see how that works. If the car is moving rightward diagonal and braking, the friction force on the tires will be leftward diagonal opposing. It means instant right turn. Yeah, it should be a left turn regardless of the braking, but I don't know why. Like, I'm just thinking it's as simple as like you want some acceleration to the left and some acceleration back in order to have them add to this result. So the backwards one means braking and the left one means turning left. Should I skip class to study for exam next week? Are you skipping that class that the exam is for? 'Cause that seems like a bad idea. Now that you'll actually... Okay, well, you probably go to class then. It's for that class? I mean... I don't think I ever skipped class. Just because I felt like it, but that's just me. Try drawing a leftward velocity vector, then find the vector difference. I mean, your velocity isn't necessarily always, like, it isn't necessarily going to end up being leftward. I don't know. It is a weirdly specific question. Looking at 12. Rafe, do all the non-trivial roots have real part 1/2? For like roots of unity? Maybe? I don't know that offhand. Hey, Bread Governor. Welcome in. How's it going? Um, I feel like I missed the part that I wanted to look at. Trying to do some algebra group theory. Ooh, nice. Without sleep and a lot of caffeine. Good luck. Are you new to the Twitch math community? Because there's actually Penn Center in this list of math streamers is doing like an abstract algebra reading group. In if you want to like discuss algebra, that's a really good place to do it. I know a tiny bit of group theory, but like it's barely any. And you're still welcome to hang out too. But when I see a new face, I like to let people know that there's a little community of us out there. It's not just me. Oh, is that the Riemann zeta function, Teratar? Yeah, no worries, Brad. Oh, you got a Hollow Nomi emote? Oh, that's awesome. Hollow Nomi's awesome. Wait, is it? It might be pronounced Holonomy. I don't know how it's pronounced, but either way, they're an awesome person. What a cook send. Oh god, that's loud. You are not perfect. That's true, a croc. What a weird. I never actually watched this show. Is that a Riemann Zeta thing? That the real part is always a half? I don't even know, to be honest. Yeah, it always looked too weird for me. Yeah, I don't know. I was never interested in it. Return the slab? I don't think so. Oh, powers of two apparently don't? What the hell is this? Rafay, I don't know exactly how to answer the question. It seems like no. I'm pretty terrible with complex numbers and whatever the heck you need to know the answer to this question is, though. Yeah, the question was whether the real part is always one half. That's the thing that I don't really know how to answer. Brainly has never lied to me. I've also probably never looked at... Oh, it's the Riemann hypothesis. Okay. It literally is just the Riemann hypothesis. Okay, fuck off. I know what I was looking at. That's when it said the cube roots of unity. Oh, I don't know, Cook. So I think those two have at least the minus a half. Hey, hello, Jenny. Dirac delta function and potentially the basics of Fourier transforms. I don't know them that well. What's up with the Dirac delta function again? Oh, that's the... Oh, yeah, it's that thing. Um... I think this is too... I don't think I can do that, hello, Jenny. I'm sorry. If I've ever done Dirac delta functions, I don't really remember them. In Fourier transforms, it's been a while. Yeah, I'm sorry about that. I only know the general idea of a Fourier transform being that you can theoretically represent any periodic function with an infinite series of sines and cosines. And I know that you can apply formulas to get what that series should look like, but that's kind of all I know. All right, what's up with number 12? I don't think this is true if theta equals 90. Because there should be no normal force but a non-zero mg. Why would it be greater than normal force? Oh wait, did I... Am I using a weird reason to remove that? Yeah, I mean, never mind. There's a way. That's just almost never true. I had that mixed up. The normal force is only opposing mg. Which theta is it? Sine theta or cosine theta, but it's only opposing a component of mg, not the entire mg. Yeah, Helgen, I've become really interested in physics. I like ENM more, but I'm trying to relearn mechanics now too. Normal force is equal to the component of weight that is normal to the slant. Was either always equal to or less than weight. Right, yeah. Thebomb.com. Hey, $10. But no, I don't really solve Sudokus at all. Yeah, and the friction force shouldn't be greater. I mean, neither of those statements are true. The friction force shouldn't be more than the force that's actually moving the block along. What's my goal? To learn interesting stuff. No particular goal, really. I feel like it's helped my understanding of math, learning physics. And it's just like, I feel like I'm learning how the universe works a little bit. Lecture major need to become Ed Witten 2.0. I don't know what that is, but I'm going to agree with it. Minority suspect. Yeah, absolutely minority. Sure. If you have a question now, feel free to hit me with it. I'm just doing some studying for fun right now, so I'm not busy. I mean, this is a physics hobbyist too. Oh, nice. Hello, Jenny. Should take a look at Erudov's theory book on mechanics. It's quite good. The vector-based approach is amazing. Oh, cool. Let me write that down, and I'll take a look at it. I have a notepad somewhere on my computer with textbooks to look into. Where is it? Can I find it? Maybe it's in this folder? Aha! Textbooksofinterest.txt. Erudov's theory book on mechanics. Nice. Going 2.0, you have to get a degree in history or linguistics. Those are undergrad. Oh, wow. Working with Zetili quantum mechanics? Oh. That's awesome, Hal Jenny. It's not confirmed yet, but Chaotic Dude has been talking about starting to stream and potentially doing something with quantum mechanics. So it's not really a promise yet, but if you're interested in quantum mechanics, there's a potential person there. Yeah, sure, minority. That one or the math discussion are fine. Is MG always... I'm thinking about number B, part B right now. I think that feels good to me. Because if it's perfectly flat, they're equal. If it's at an incline, MG is a bit greater. And if it's completely vertical, N is 0. And MG is positive. Or, you know, it's not 0. So I think I like the first part of B. Is it true that MG is always greater than or equal to F sub F? I think so by a similar reason, because the friction force is going to be 0 if it's flat. non-zero, but still something. Are they ever equal? I don't think so. So B feels good, but let's see if we can eliminate the other ones. My knowledge of quantum mechanics is somewhat limited to Griffiths and some sections of Cohen. No real knowledge of QM is needed for the ancient quantum stuff in math. Oh, really? Force of friction could be arbitrarily large depending on the coefficient of static friction. Really? It's never when the force... Okay, yes. C is just generally not true. I think your coefficient of friction would have to be equal to 1. It might be mu s. I might have that subscript wrong, but friction force plus normal force is equal to mg. I don't think so. Wait, I'm thinking that, like, I'm kind of... I know that it should be mg... Oh my god, I can never do this, but, like... I know you have to break up gravity into its components. But mg is greater than mg sine theta. Or equal to. So that's why I wasn't really worrying about the components, because we're dealing with the bigger thing anyway. And that's also true for cosine theta. C is clearly false for theta equals 0. Oh, okay, yeah. Yeah, I mean, and I feel like it's only ever true in, like, that special case where the coefficient is 1. E... Why can we eliminate E? The force of friction is greater than the normal force if mu sub s is greater than 1. No, not if theta equals 0, right? Is that how we can... Because otherwise it seems true. Or maybe theta equals 90. Yeah. Alright, so I still like B. Yeah, B. Okay. Nice. Ellie, the highest grade on the project was a 71. We all got destroyed quite... It's... Oh my god. Rest in peace, grades. Minority Suspect, did you post your question yet? I just want to make sure I'm not missing it. Yeah, sure, critical. You sent them to the homework help. Okay. Okay, nice. Oh wow, you got a whole lot of them here. Are you asking about a particular one here, Minority? This is a lot. If you did 11 right to start. Okay, let me find 11. Okay. Um, okay, so yeah, we have an alternating series, minus 1 to the n over 1 times 1 over n to the 4. And so you're checking the conditions where the positive version of the series is decreasing. And the limit goes to 0. Right. So I would say I agree with your work. I'm just gonna like nitpick the phrasing a little bit. Where once you get to this like this second thing where you find the limit is 0, you've done the alternating series test and you know that it converges. And then in the second stage, you're looking just at the series 1 over n to the 4. And you know that converges by a p series. And because both of those bits, both the alternating and non-alternating versions both converge, then you know it's absolutely convergent. So as long as you're clear on that distinction or like what's actually happening, I think this is perfect. I guess we'll make sure that you know like what exactly you're proving at what point. It might be good to do that, yeah. Like since a sub n converges, since it's a p series with p greater than 1, would be like plenty of justification to my eyes. I'd approach 3, 4, and 9. Here's 3 and 4. Why is it as... one second. I hate how the image... If I don't get the link from the right place, Discord gives me a crappy version of the image. See, that's way better. Okay. Well, that's a tricky one. Not 4? Okay. How do I deal with this one again? Roto, 1 to the power of 0 is still 1. Indeedy, what's your question? I'm helping out my minority suspect on this question, another one, and then I'm helping out critical thinking. Oh, Mina, nice call. That's probably the integral test. Yeah, critical. I want to get through my minority suspects questions. I think they're quick, and then I'll look at yours. Okay, we'll do critical. Okay, yeah. So this series is positive and monotonically decreasing. So you can use the integral test here. You can look at whether the integral from 2 to infinity of 2 over n ln n converges. I'm sorry, you usually use x's when you do this. It's not really important, but... and you can do this integral with a u sub. U equals ln x. Du is 1 over x dx. So is that enough to get you started there, minority? Mina, show that for the number of Euclidean dimensions, the sum of two. Oh. I don't know how to do that, Mina. I'm sorry. Okay. And so the other one you wanted to see was 9? No worries, my minority. Okay, I see 9. One over n squared plus 1 to the n. Oh, so yeah, this should be nth root test. Do you know that one? Oh, does that become 0 though? That might be an issue. Divergence test? The element should go to 0, I think. I don't know how to do that question, Roto, I'm sorry. Wait, what's the deal with the root test? Anytime I see n in the exponent, you like 99% of the time that's a root test. All right, see you, Cook. Thanks for hanging out. Okay, yeah, so I think even if we're getting 0, that's okay. You would set the limit as n goes to infinity of 1 over, oh, let's do 2 stages of parentheses, n squared plus 1 to the what am I writing? To the n to the 1 over n for the root test. And so you're just going to get limit as n goes to infinity, 1 over n squared plus 1, and that becomes 0. And so I think by the root test, this thing was going to converge. I think the test for divergence, I don't know exactly how to show it, but I think you do get 0 if you let n go to infinity of the original thing. And so the test for divergence doesn't apply. Yeah, DD, I see it. I don't know how to deal with those though. I'll show it on screen if someone wants to take a stab at it, but I haven't done that part of linear algebra. Minority, let me know if that makes sense. So I don't know how you deal with these like polynomial vectors. I haven't learned them, but if someone wants to like give a hint to DD, it helps. Awesome. Oh no. Critical's question is dielectrics. Should it? Oh, is there a more efficient way? Uh, I don't know honestly. Fenlox is saying ease dependent. Roto, I have no idea what that means. Oh yeah, Critical. I was just looking at your question, like without showing it, but I haven't done dielectrics before. Some of the first two terms is minus three times the third. Oh, nice. So yeah, DD looks like you can try and guess and check, and like if you're good at it, you can figure it out faster. So what Fenbox and Skeleton have noticed is that in part E, if you take the first two and add them, you get negative three times the third vector there, or thing. So that is a more efficient way, but you have to be good at guessing and checking. So yeah, critical for this one. I don't know how you do this one. I'm sorry. I haven't done anything with dielectrics before. All right, sorry about that. Hey, adios. Uh, can you explain the arithmetic progression formula, how it works? I know what that is offhand. Uh, an arithmetic progression in general just has like you're always adding the same amount every time. Go away. Adios. Why you spamming? Ugh. All right. Bye, adios. You're annoying. Uh, adios, adios, one might say. Wait, how did you get a message through after that? Or is that YouTube just bugging? All right, well, I'll see if he spams more. Uh, oh yeah, Mina, I guess that makes sense. I don't know how your stuff, or like how the thing you're doing works, though, to be honest. Um, and so Sarthak, for your arithmetic progression thing, I'm not sure exactly how it works offhand, but I won't get this question first because it was posted first. Actually, I don't know that I can do this one either, though. I can see that, like, this complex number on the inside has magnitude 1, and so we should, and this is only ever going to be like 1, -1 I or -I. And so I think theoretically we should be getting some repeating values or something like that. Like, um, I'm not quite sure exactly how to do this. So I feel like I can understand a solution to it, but I don't know if I'll be able to solve it on my own. Awesome, dude. Is there a better way to solve word problems? I'm in Calc 1 and comprehending the words to the question is really confusing. Um, yeah, it is just confusing, unfortunately. Are you doing like related rates word problems? Roto, are you actually asking like are you asking like a question you need help with? Or are you just like trying to quiz me right now? Can you split the I to the n part and the rest, and there should be 8 different cases of that loop? Yeah, this feels like it should loop in some way. It doesn't feel like it, Roto. I feel like you're just kind of asking me questions. Can we do more problems with derivatives? Example of one. Yeah, an example is always really helpful here. Um, oh, you know what? I bet you need to make this exponential. That might make it more clear, right? All right, awesome, dude. I'll copy your problem down and I'll try and talk about it after this question. Well, I think it's going to take me a while to work out this complex one. Maybe I'll try and talk about yours first, because I think this will be a quicker explanation. I'll keep that other one like on the screen though if someone wants to like look at it. Hyperbole is 100 feet above the ground. A motorcycle traveling a straight line passes directly beneath it, going 60 miles an hour divided by 60 miles divided by an hour, or 88 feet per second. Oh, okay. So for these, it always helps to draw a picture. Okay, sounds good. Critical. The questions are starting to like pile up a bit, but I'll at you in chat when I get to yours. Okay, so they give us oh my god. Why are people just spamming? Okay. So I always want to draw a picture in Skeleton. I see what you're saying. I'll come back to it in a minute. Yeah, so like for these calculus questions, like a picture is worth 1,000 equations. I don't know. Hot air balloon, really crappy one. And then the motorcycle. Who cares? That looks like a tricycle, to be honest, but you know. I always like to draw a picture of these, and it's gonna end up being a right triangle. It's always gonna end up being some kind of clean geometric shape because you're in like, you know, just like a normal like calculus class, I bet, and they're not gonna give you anything that's that weird. So we know at this instant when the motorcycle is directly beneath the hot air balloon, they're 150 feet away, and the motorcycle is going 60 miles an hour. Well, let's do it in feet per second, I guess. And the hot air balloon is going up at 10 feet per second. And then they're asking about a point in time 9 seconds later. I also try to came here to look at the spam. I think I deleted it all. At least I hope that gets deleted for everyone in chat, because I don't know why people are just having a problem with me, I guess. Okay, so the distance between them is like the hypotenuse of this right triangle here. So if this is side A, that's side B, and that's side C, we're interested in how C is changing with time. And so it's always helpful to think about what's changing and what's staying the same. A is always 150. B, actually, no, I'm sorry. A is increasing because the balloon is going up. B is also increasing because the motorcycle is traveling to the right. And C, we expect it to be increasing because they're getting farther away from each other. So the first thing that I would do is try to get the bottom side of this right triangle, which is it's traveling 88 feet per second for 9 seconds. So we do 88 times 9, whatever that is. We find out. But maybe I won't go through and solve the entire question because there's a couple of questions in chat now and I don't want to spend too long on just any one question. But like the way that you think about these is like I just always draw a picture and then you think about what's changing and like what you ultimately want to get. So we know at any time that a squared plus b squared equals c squared. That's the Pythagorean theorem. And we know they're changing in time. So we can take the derivative with respect to time of this equation. So I'll do d by dt of both sides. And here, a, b, and c are functions in terms of time. They're not just constants. So the a will become 2a dA dt, and this is because of like implicit differentiation. I hope you've learned that, and this hopefully makes sense. But if not, let me know. dc dt. And so from here, you can actually just kind of plug things in, and they want the rate of change of the distance between the motorcycle and the balloon. So the thing we want is dc dt. And we know what all of these other things are. So the distance a is 150, 2 times 150. And the balloon is moving up at 10 feet per second, so dA dt is 10. Plus 2b, we said is 792. The motorcycle is going to the right at 88 feet per second, so dB dt is 88. And I didn't find what c is, but you could use Pythagorean theorem to find what c is at this instant and just solve it for dc dt. But yeah, the biggest tip I can give you is draw a picture, I think. And then think about what's changing. Hey, Sarah Ram. Okay. I'm going to delete this. Actually, YouTube has really easy rewinding, so I'm going to delete this and try to think a little bit about this complex numbers question. So what does taking the derivative of both sides do? Yeah, the Pythagorean theorem that I said of a squared plus b squared equals c squared, that only applies to when nothing is changing. But both sides of the triangle were getting bigger with time. And so that's why we need a derivative. So we want to figure out what rate things are going at. And that's exactly what calculus does for you. So if something is like changing, or if you want to figure out how fast something is changing, that's the exact situation you want to use a derivative for. Because a squared plus b squared equals c squared on its own will only get you at any point in time, like what the distance is. It will never get you the rate. You have a good idea about the complex number problem? I think the answer to a, b, and c are all 3/2. Part b is 1/2. I think b is 0. Okay. No worries. Awesome, dude. Kodak. Thanks for looking at Roto's problem. I'm not sure why you're typing in all caps, but it seems like you figured it out, so. Okay, so 1 plus I over root 2 to the n is the same thing as e to the I pi over 4n, right? Oh yeah, Skeleton put what it is before. Yeah, it is. Okay. Is there any benefit to translating that to exponential? I don't think so. So if we want to maximize the real part, oh yeah, absolutely, Lars. I should have explained that more. So if all I did is I focused just on the thing inside the parentheses and translated that to exponential, or to polar. So 1 plus I over root 2 is the same thing as 1 over root 2 plus 1 over root 2i. And I just know the unit circle well enough that I know that the point 1 over root 2 comma 1 over root 2 goes with an angle of pi over 4. If you don't know that, though, you can do arctangent of y over x, or, you know, imaginary over real. And that would be arctan of 1, which is pi over 4. And so that gets you the pi over 4 angle up there. And we know it's a point on the unit circle, so we know that the magnitude of this thing is 1. So there's not like, there's just like invisible 1 coefficient in front that we don't have to worry about. So as soon as I did that, I just kind of knew that we could say the same thing as e to the I pi over 4. And so if you plug it into the original thing, 1/2 parentheses e to the I pi over 4 to the n, you can just use exponent rules to multiply the n inside. That is cosine plus I sine. Okay. Hey, Gonzalo. E to the power of I plus pi plus 1. I'm not sure what that is. Makes sense. Awesome. Glad to hear that part. No, I haven't worked out how to actually get the supremum or infimum, or I haven't worked out A, B, or C yet, but do we just kind of guess and check with values of n here? Like, there shouldn't be that many to check, I feel like. I think there should be something better. There should be a way to, like, figure it out. Oh. Okay, wait, maybe I understand what you're saying now, Skeleton. Maybe it's better to put it in So we could also take this exponential and put it in terms of cosine plus I sine using Euler's formula. And I kind of wonder if that is better. Cosine I over 4n plus I sine, a half. I sine pi over 4n. And then we can group the imaginary parts with each other. Oh, I mean, it's not like that clean, but we need to know the real part of this thing. Well, no, that's not that clean, is it? Maybe we do want to put I to the n in terms of polar coordinates as well. I kind of want to get everything with cosine and sine. Yeah, I thought we could view it separately. There probably is a way to view it separately, but I don't actually see how you do that, personally. I'm not very good with complex numbers. Right, ISCIS. Yeah, it's like, how to deal with the power. Like, should I put it as an exponential first? I is just e to the pi over 2, like I pi over 2n? Is that what we want? And now if we put both of those as trig, pi over 2n plus I sine pi over 2n plus 1/2 cosine pi over 4n plus I sine a half sine. Okay, so all I've done is taken those exponentials and put them in terms of cosine and plus I sine. And I'm hoping this gives us something that's relatively easy to analyze for a supremum. Because the real part of this is cosine. Oh, is this always something? No? I to the n is equal to... Okay, yeah. Can be somebody using trig identity. I mean, you could say it's always like -1 to some power, but I think I'd rather have it like this. I think, at least. I'm not the expert here. Cosine pi over 4n. So this is the real part. Just rearranging the thing in the last line. The imaginary part is sine pi over 2n plus a half sine pi over 4n. I really, like, we could use a half angle to make the angles match. That feels so cheesy, though. Gonzalo, I see your question. I'm working on this question. There's another one that's waiting to be answered, and then I can look at yours. I think the quick answer is that you're going to take that expression for velocity and integrate it from 1 to 4. That's my first impression of looking at that question. You were asked what is I to the I in an interview? Is it that? I was kind of like, I guess it is, yeah. Sounds good, Gonzalo. Yeah, that is weird. Okay, if we did use a half angle or double angle, that feels so dirty. Like, I feel like there should be a cleaner way of doing this. It's not the full answer? Really? Two cosine squared minus 1. So we're going to take the pi over 4. Ugh, I need to copy down this identity. Okay, so I think we want to take the pi over 4, but theta equals pi... No? Okay, if theta equals pi over 4, then cosine of pi over 2n equals 2 cosine squared pi over 4n minus 1. So then that first bit... No, this isn't helpful. There's no way. The cosine gets squared. I think that's overkill. Can we just look at this and know what it should be? Maybe we do want to simplify it. The clean way to this is no trig. Is it, Benbox? I don't know how to do it without trig. I don't know how to do it with trig either, to be fair. It's like, I don't know what, like, I assume like you maybe got in this form and then did something, but I don't see where you go after that. Oh, is it just... Oh, wait, okay. Maybe I do see it. Okay, scratch this stuff. I think it's way... It's probably more than is necessary here. It's definitely more than is necessary. I think from here, we can just know, like, we can just look for value of n. Like, we know at best that piece of the function can be 1. And at best, this piece of the function can be 1/2. So as long as we can name an n where that actually happens, I think we're in business. Awesome, Gonzalo. Thank you so much. Can't wait for Monday. What's on Monday, 7:50? So in order for I to the n to be equal to 1, n should be 4 or a multiple of 4. Your input teacher trying to do 1v1 on OSU? Oh, nice. That's cool. Aware BTTV emote. I don't think I have that one installed. I could add it. Or like added, not installed. So if I equals 8, or sorry, if n equals 8, oh my god. I think we're doing the best we can, which is we get I to the 8 plus 1/2 e to the I pi over 4 times 8. Probably I equals 0 is simpler. Or n equals 0. Oh my god, dude. So yeah, if n equals 0, we get I to the 0 plus 1/2 e to the 0, and that's 3/2, right? Well, maybe a little more. 1 plus 1/2, which is 3/2. Okay, that's a lot simpler, I think. Just think about like what it can be at best. So I think the supremum for part A is 3/2. The infimum of the imaginary part. Okay, well, we want it to be purely imaginary. So all this is part A. For part B, the least imaginary thing we can get, that is at best minus I, and that at best is minus I over 2? You're still wrong on B? Oh, okay. Hey, Essen? I don't say your name, but hey. 3/2 is correct? Awesome. Define all integer solutions. Oh, I'm sorry, I don't know how to do that one, Essen. So in order for I to the n to be equal to negative I, we want it to be 3 or a multiple of 3n. In order for this to be purely imaginary, let me say like n is equal to 3 times some number n from that chunk. From this chunk, in order for e to be purely imaginary, we want it to be e to the minus 3 pi over 2. Hey, computer guy, how's it been? 3 pi over 2. So multiples of 6, I think, is where that happens. And so I think our first one where that happens is n equals 6. So we should get negative 1 plus a half e to the 3 pi over 2, which is negative I. Sorry, that's minus I. So minus I plus 1/2 times minus I, which is minus 3 over 2I. So I think that's the infimum. Oh, sorry, they're saying of the imaginary part. So the actual answer is minus 3 over 2, I think. I'm doing good too, thanks for asking. Because I removed the I because they're asking for the imaginary part. 1 minus 2 root 4? 2 over root 4. Root 2 over 4. Haven't I named an n where we get less than that? Root 2 over 4 is a pretty small number, right? It's only a little bit over 1, and this is 1.5. Check I to the 6. Oh, did I not do that right? Oh, I didn't do that right, did I? Ah, okay. You're right. So yeah, it needs to be an odd number. That's just completely wrong. It should be a knock. That's, I'm not sure what you're asking there. Find the Fourier transform for that function? It should be a multiple of 4 minus 1. That's the real answer. Oh, so do these never overlap? Well, no, I think they never overlap. Man, can you even find it systematically then? You drew 8 little pictures, look like minute, hour hands on a watch. Kapil, I'm not sure how you do that problem, I'm sorry. So Femox, you literally just drew a bunch of a picture. Like you basically just checked all the cases, it sounds like. I guess that's what you have to do. I don't know what else you can do. All right. Well, I guess if n equals 0, we get positive 1 plus a half. If n equals 1, we get I, and we get root 2 plus root 2 over 2i. Oh, I guess I can see how you maybe the rotation is making more sense now. Then that one becomes 1, and then this one goes right there to -1. N equals 5. Yeah, Lars, I'm not sure if you are still here. I'm sorry if I took too long you had to go. It seems like this one is possible to just brute force it by looking at all the possible values of n. You are? Okay. Thank you for your patience with me. I'm not very good at the complex numbers. I've never actually taken a formal class on them. I just like followed along with like a virtual class. But if it's not clear what I'm doing here, I'm literally just taking this formula and plugging in values of n. And so the first thing, like, I know that I to the n. Oh, wait. No, yeah, I'm good. It's your 5th week of math major? Oh, wow. Good luck. I know that I to the n is always going to be 1, I, -1, and -I. And it's just going to rotate around from those 4 points. So if n equals 0, I start at 1, and then it rotated up to I, then to -I. That's -1. Sorry. From -1 to -I, and now that part is gonna repeat. So it goes back to 1, then I, and it's gonna keep on rotating around at 90-degree angles like that. The second chunk, it has length 1/2, and the angle up here represents a 45-degree rotation. That's what pi over 4 degrees is. So when n equals 0, it starts out as just the real number 1/2. But then you rotate counterclockwise, pi over 4, and you get, yeah, this is on the unit circle, so root 2 over 2 plus I root 2 over 2. Then this one rotates 45 degrees again, becomes purely imaginary to 1/2 I. You rotate 45 degrees again, you get quadrant 2 on the unit circle. And so I'm just doing those rotations every possible case, and I know that it's going to start repeating itself once that part returns back to wherever it starts at 1/2. So there's not going to be that many. I have maybe like 3 more cases, 4. So I ended off here. So this I comes over 90 degrees. That's -1. This becomes negative imaginary, and that's always going to be -1/2 I. N equals 7. The -1 rotates 90 degrees. to be negative I. This one rotates 45 degrees. So, nope, at root 2 over 2 minus root 2 over 2i. And okay, now this next one should be our last case. Because 90-degree rotation gives us positive 1, 45-degree rotation gives us 1/2. And that agrees with n equals 0. Okay. So now we just get to look at all these pictures of all the different cases and decide which one has the minimum imaginary piece. And that seems to occur here at n equals 7. Because we have negative I and minus root 2 over 2i. So that's how Fenlock's got his answer, I see now. So the least imaginary piece we can get is, or like, the imaginary number that we're concerned with is negative I plus root 2 over 2 minus root 2 over 2i. And we're concerned with the imaginary piece, which is negative 1 minus root 2 over 2. Okay. Ah, you're right. No, are you? You're right, Fenbox. They should be. Crap. I neglected this. I'm getting my unit circle. Oh my gosh. Okay. I was getting mixed up with the 1/2 here and the 1/2 that's already included in the unit circle. So yeah, Fenbox is accurately pointing out a mistake that I made. All these unit circle values should be divided in half. Oh, this is painful. Nope, that's not the right thing. That's not the right thing. Those should all be 4s. Dude, I'm clearly not clicking on the fraction bar. How is Journal++ this inaccurate? There. What? Oh my god, dude. Okay. There we go. Yeah, you can. I just, for some reason, refuse to. Is it hard to read? Or are you just saying that because I'm struggling to click on the right thing? So that should also be over 4. Okay, so I'd say that that's our infimum. -1 minus root 2 over 4. And I don't know a better way than get some check there. What's the supremum of the magnitude? Looking back to our cases, we have a bunch of cases where that happens. I think it's, well, the magnitude of both these is always constant, isn't it? They're sometimes canceling. Maybe. But, like, we could look at this case here. It's magnitude 1 plus magnitude 1/2. So I think that's 3 over 2. You can do the same thing, like, over there. I think that supremum of the magnitude happens in a bunch of places. Okay. Watching Penn the other night, streams physics. Oh, okay. Yeah, I would need to look if there's an easy way to, like, zoom in. I tend to resist doing that because it can just be a pain to zoom in and zoom out all the time, but if there's an easy way to do that, I should probably take advantage of it. I just would need to, like, look into it. So yeah, Lars, I'm sorry that was a crappy explanation, but let me know if that makes sense. The best way that I, like, as soon as I ran into an issue trying to do the infimum systematically, thinking about, like, what multiple things should be, I think the only way to do it is, like, look at cases. It does? Okay. Thank you for your question. bam. Okay, let's go on to criticals. No worries. I feel like I learned something there too. Or I definitely did, so it was good for me to do that. Oh, okay. They don't even they don't even give you some crazy description of what this region should be, thankfully. Oh, awesome, you're here. Critical. All right, so they want you to integrate over this volume they define here. And I think without thinking too hard, like, we can take these as our bounds for each variable and not have to do any kind of crazy visualization here. So I'm going to set up a triple integral. 1 over x cubed. And I'm going to go from right to left. So I'm going to start with integrating x. You can tell, oh, okay. So let me know if you get the same setup here for the integral. So they're giving us directly that x goes from 1 to z plus 1. And then we'll do z. Okay, nice, yeah. And they give us that z goes from 0 to y squared. And then we do y, and we know that y goes from 0 to 1. Okay. So on the inside, we just have an integral with respect to x, and we can do that. 0 to 1, 0 to y squared, those two outer integrals stay the same. 1 over x cubed integrates to minus a half 1 over x squared. Yep. And that's being evaluated from 1 to z plus 1. dz dy. So now anywhere we see an x inside here, we plug in the upper bound minus the lower bound. Wait, okay. Yeah, what's up? It's not z over x? No, we're... At this stage, no z's are getting involved. The only z is like what we're about to plug in from the bounds, but there's no z's originally in this integrand, and we're integrating with respect to x. No, there's no way for a z to pop up at this stage. Like, you could boil it down to just doing 1 over x cubed dx for this first part. Like, the answer to this problem is what you put inside there. Yes. You make it x to the negative 3 dx, and then you do your power rule. Yeah. X to the negative 3 plus 1 divided by negative 3 plus 1. And that's where I got my minus a half. And I'll write x to the negative 2, but then x to the negative 2 is also 1 over x squared. Like that. And so I'm writing it like separately. You could also write it as like 1 over 2x squared. That's the exact same thing. Yeah, the process that you're putting there in chat is perfect. From there, you're not sure what to do. Okay. So can I do Laplace transforms? I can do like the basics of Laplace transforms. I'm pretty rusty on them, Rob. So from here, it's still the exact same as a normal integration problem with bounds. Anywhere we see an x inside here, we'll replace it with z plus 1. Subtract, and then anywhere we see an x, we'll replace it with 1. So what we're going to get, 0 to 1, 0 to y squared, minus a half. Ooh, I dropped the minus sign on that one. So 1 over, now x squared, but in order to see x, we do z plus 1. So 1 over z plus 1 squared minus a half times. Now there's an x, but we plug in 1. So 1 over 1 squared dz dy. Are you still with me here? Yes? Okay, good. And so at this stage, we should never have another x popping up in the problem. If it does, you've probably done something wrong. We've integrated x, and we're kind of like done with it right now. We're solving for a volume, and we should just get a single number out because a volume is just a number. So I'll clean up the numbers we have here a little bit. Do I separate the constant place in front of the integral? We can do that here, yeah, as long as we're careful about it. So I'm gonna just take a step to clean this up a little bit. C plus 1 squared. We have this thing in here is negative a half, and then we're doing minus. So we should just get plus a half. If you're gonna do it here, you need to make sure you're factoring out the 1/2. So I normally don't. I just feel like it's a little bit of extra work for not a lot of gain. But if you prefer, you could take a 1/2 and put it in front of the integral here. You just need to be careful to take the 1/2 out of both the terms, that one and that one. Plus 1. No, when you factor out the 1/2, you're dividing each of these by 1/2. And dividing by a half is the same as multiplying by 2. Because you multiply by the reciprocal. And I think the easier way to remember that is that if you multiplied the 1/2 back in here, you should get a 1/2 over there. So that's the way you can kind of like do a check there to make sure that you like divided right. I prefer without taking it out personally, because I feel like the 1/2 in front is just like another thing to keep track of. But it's valid. There's nothing wrong with doing it as long as you're careful. Let's do it without? Okay, we can do that. So yeah, normally if I was doing this on my own, I would just integrate this from here. That's a terrible box, but we have an integral in terms of z. Oh, this is an annoying... Ugh, okay. Oh no, it's not that annoying. I'm going to do some side work though, because this integral here is it is slightly annoying, and I just want to do that on the side where I can focus on the problem there. So I want to figure out what 1 over z plus 1 squared integrates to, and I just want to do it without cluttering up the main work over here. So we can do a u sub. U equals z plus 1, du equals dz, and so that integral is the same thing as 1 over u squared du, and that's a power rule. So I'll rewrite it as u to the negative 2 du, and so we get u to the negative 1 divided by negative 1 So negative 1 over u. And then we unsub, and we get negative 1 over z plus 1. So that's just the side work to work out this piece of the integral here. So 0 to 1. We have now done that first integral. So this piece integrates to negative 1 over z plus 1. So, and there's a negative out front. So this becomes positive. The 1/2 stays out front. And then the 1/2 integrates to 1/2 z. And we're writing from 0 to y squared dy. And so now we're going to do the same thing where anytime we see a z, we put it in a y squared and then a 0. So assuming that you're with me so far, I'm going to proceed. Yes? Okay, good. So we're starting with y squared. So we get y squared plus 1 plus 1/2 y squared. From the first bound, now we do minus, parentheses, 1/2 times 1 over 0 plus 1 plus 1/2 times 0 dy. Let's clean this up. 1/2 times 1 over y squared plus 1 plus 1/2 y squared. Okay, that's just 1 over 1, and that's just 1, so we don't care about it. 1/2 times 1 is just 1/2. This thing over here becomes 0, so we can forget about that. So we're just left with this integral here. And now this is just a normal, like, Calc 2 problem. It's basically like 3 Calc 2 problems in one. They're all just like the same thing as a single integral, they just look harder. This we should recognize as arctan or inverse tangent. The 1/2 stays out front. So we get 1/2 arctan y. This is a power rule. We have to divide by 3, so we'll get 1 over 6 y cubed, and the 1/2 becomes 1/2 y, and we evaluate from 0 to 1. Now let's plug in our bounds. Oops. So 6, 0 cubed minus 1/2, 0. Okay. Arctan of 1 is pi over 4. Pi over 4 times 1/2 is pi over 8. The second term is just 1/6. The next term is just minus 1/2. Arctan of 0, it should be 0. Yeah. And all these, the other two terms become 0. So we just have this. Let's combine the 1/2 and the 6, and then we're done. It should be a third, right? No, 2/3? Yeah, negative 2/3. So I say that's our answer there. I think it's 1/6 minus 3 over 6. Oh, it is 1/3. Good catch. Yep. Because minus 2 over 6 is minus 1/3. Yep. That did feel weird. Subtracted to the u sub and the arctan. Oh, okay. Um, if you have something that is exactly like this, then sure. Yeah. It's not as clean as a u sub if you have something like z squared on top. It might actually still be that same u sub, but it's a little more complicated. But if it's just something like this, you can always do a u sub there, yeah. If it looks even a little bit different though, it could get a lot harder. No worries. Your cat has a word math problem? What's up? I do gotta use the bathroom, so I'm finally a little break in the math, so I'm gonna BRB. Just be a minute though. Okay. It says cat minus food equals hungry. How long will I need to wait until someone gets me food? Look at his full food bowl. He's not great at math. uh, your cat is my spirit animal. Um, I had cats growing up, and I miss them. They're little assholes, but their antics are really funny like that. I remember one time ants got in my cat's food bowl, and one of them came running up to me with like the most heartbreaking meows you've heard in your life. Like he was in such like distress over ants. Like it's like, oh, it's just like they just really care about their food. I don't know, like shamelessly. Food all gone, yeah. Hmm. I mean, I wouldn't want to eat ants if they got in my food, so I guess I can't blame them. Okay. The block sits on a plane. There's friction between the block and the plane. Oh, did you ever get your like bike power situation going? I remember you were talking about that a while ago. Block sits on a plane. There's friction between the block and the plane. The plane is accelerating to the right. The block remains at the same position on the plane, which is implying that pictures might show the free body diagram for the block. Doesn't this depend? Ooh. Okay. You got one part and the project might not. Oh, okay, dang. It happens. This feels like a relativity question. Like, wouldn't this answer change if we were also on the plane? Uh, if we were on the plane, it would just have a normal force straight up and a gravity force straight down. We wouldn't know that we're inclined either. Or we wouldn't feel inclined. Um, but we're presumably observing it from, some other point where we see it at an incline and accelerating to the right. A little expensive. So sadly, we'll have to be once I become YouTube famous or someone sponsored me. Just got to get that YouTube money. Hey, Rostislav? Uh, I can do differential equations that you would normally find in like in undergrad, like differential equations class. So if you have some crazy differential equations or like partial differential equations, they can do them. But if it's like a regular ordinary differential equation, I can take a look. Feel free to just like post your problem, and I can tell you if I can or can't do it. Oh yeah, thank you so much for the kind words. Oh, I'm not keeping track, but I appreciate it. DoorDash is making pretty good. Can't blame too much. All right, yeah, if it's working, it's working. I feel like I'm being tricked here. Uh, I think it's just C. I was trying to justify why it wouldn't be A. Like I was basically debating between A and C. Oh yeah, sure, Rostislav. Um, you can type them out there in chat, or you can put them in my Discord. Yeah, sorry, I had people ask me if I can do differential equations before, and I say yes, and then they hit me with some crazy, like, partial differential equation that's like, they hit me with some crazy stuff. So that's why I'm always cautious when people ask me that. But yeah, if it's on the AP calculus exam, I can 100% do it. Okay, I think I'm going with C here. I'm a little bit worried that it is A, but it's like the plane is accelerating to the right, and so I'm not really sure what to like. I feel like it's not the blocks. It is C. Nice. Okay, good. Assume the block remains in the same position on the plane as non-zero ax but zero ay. Given ax positive was one of n plus the positive or negative or zero horizontal component ff must equal max. If we point down along the plane if ax is larger than a certain value. Exercise you can determine this value. Really? Oh, if it's larger. Oh, okay. I might want to take him up on their exercise. That seems interesting. All right, so that angle is theta. Okay, so we know that given ax the positive horizontal component of n, so this thing has a net acceleration ax. So we have this weird, like, yeah, it's going to be a if I like if I draw things perfectly like perpendicular, the normal force is going up and to the right like that. The friction force is going diagonally like that. So we do have to look at components for a lot of stuff here. Thankfully, mg is still straight down. And I think that angle there is theta. And my drawing is a little bit small. Why do I always... I remember my drawing is the proper size. What's the... How can we work out the angle for the friction? I think it's... Oh yeah, it's just theta. Or like just like the theta goes right there. Okay, I need to make this thing bigger. Can I... If I upscale it, how is that going to look? Oh, not bad. As it turns out. All right, so we want m a sub x is equal to and we want the horizontal component, which should be sine theta, plus f sub f cosine theta, if there's one component of friction. And so are they asking us to isolate f sub f here and figure out when it changes directions? Or maybe... Okay, yeah, I think so. M a sub x minus n sine theta is equal to f cosine theta. Yeah, Rostislav. You can put it in the math discussion or the math homework help channels on that Discord server. Let me know if you can't find them, and I'll at you. All right, so in this case, cosine theta is always going to be positive, and so we can just be concerned with when the numerator is equal to 0, I think, because that'll be the critical point. So a sub x is equal to n over m sine theta. I think that does work out dimensionally, right? Yeah. So it starts to go backwards. Or it will transition from going... Wait a second. How do we interpret this? Here, I'll at you, Rostislav. So the normal force okay, so the friction is going to start to point, the friction will point to the right. If like it's because of the relationship between the normal force and A, I guess. The normal force, damn it. I think it's a cool relation to be had here, but it's really, it's eluding me. Maybe not a really cool realization, but I feel like it's an important thing to figure out about how this normal force is behaving. As A sub x increases, the normal force is also increasing. And the normal force, why would it eventually switch though? It's always pointing in the same direction. It's just that the length of the arrow is getting taller, right? No, I don't think the normal force is getting... The normal force is only existing to counter the vertical component of gravity. You know, I don't know. I can imagine intuitively what will happen, but I have a hard time putting in physics terms what will happen. Like, it doesn't make sense that once you're accelerating fast enough, that block should start to slide backwards. But I'm having a hard time identifying which force is actually responsible for that. A block with mass m sits on a frictionless plane inclined at angle theta. Oh, they might be about to test me on that right now. Let's see. The plane accelerates to the proper acceleration causes the block to remain in the same position in respect to the plane. Was the normal force between the block and the plane? Wait, why is that figure so high up, by the way? There's so much blank real estate they could have used to just shift it down. That really bothers me. um, a block with mass n sits on a frictionless plane inclined at angle theta, as shown in figure 4.7. The plane accelerates to the right, the acceleration that caused the block to remain at the same position with respect to the plane was a normal force between the block and the plane. Nope, I'm drawing that wrong. Ugh, that's too small. That's what she said. This is still pretty small. But I already drew it, so we're sticking with it. This is a frictionless plane. So coming back up here, the normal force basically has to compensate for the friction not being there, I guess. So draw our perpendicular axes. We need to break up the normal force into its two components here. But isn't... How can the x directions possibly cancel if gravity... They seem to both be going to the right. Like, gravity's x component goes to the right. And if the normal force is tilted like that, well... Yeah, I mean, its exponent should also be going to the right. So what gives? That's the same realization that I was missing in that last problem. It must be that the normal force is somehow pointing to the left of the plane, but like how? If the entire vector is pointing up and to the right. Rostislav, are you still around? I haven't seen your question yet. I'm probably not going to stream for a ton longer, so if you're going to have a question, then let me know. So, like, just think about it intuitively, C or E feel like they should be the only right options because I do expect some weird asymptotic behavior for something that's perfectly flat or perfectly vertical. You're gonna head out? All right, computer guy. Thanks for hanging out. Hope you have a good night too. I should turn the light on. It's getting darker earlier now. Wait. So the issue with like my idea of like there should be some weird behavior for perfectly flat or perfectly vertical is that each of these options, they have normal behavior depending on for one of the flat or vertical cases, which doesn't make sense. So it's flat, there shouldn't be any value that works, which makes me think sine theta that gives 0 when theta equals 0 is right. But then if you have something that's vertical, so theta equals pi over 2, you get just mg. Is there a justification for that? Like, I feel like in either case, it's not possible to maintain the constraints of the problem because if it's vertical, the block should fall straight down. It will be... So it's not going to remain in the same position with respect to the plane. Same with its vertical. There's nothing the normal force can do to fix that in either case, I don't think. So it seems like... I don't know how to justify... I don't know, like you could say it's maybe E? Because that always matches where if theta equals 0, the normal force is just mg. But it's still violating the constraint of the question. The block is going to slide, I think, because it's frictionless. So I think I'm leaning towards E from that rationale. But can I actually, like, I should be able to show that somehow. I see maybe it's joined again with a different account. Maybe having some difficulties. Hopefully you can get it to work, Rostislav. Ugh. I'm really confused about this normal force thing. Does the normal force, am I not drawing the normal force right? Could that be the issue? The normal force, it should be opposing both gravity in whatever this acceleration is, right? It's still going to just be tangential to the plane, though. Okay, can I... It must be that M A. I mean, I'm going to drop the X because we're only talking about horizontal here. Is equal to n sine theta minus mg also sine theta? Hey, Meryl. So I can help with anything up to like a first or second year undergraduate like math class. So things like algebra, pre-calc, trig, calculus, like those are my bread and butter, stats. Computer science, algorithms and theory, not coding. Sort of. I do have a minor in computer science. I'm not as strong on computer science stuff. If you have a question, I'll like take a look at it. It's not my strong suit though. No worries. Oh wait, you know what? This isn't even right. I think it's actually the normal force is equal to mg cosine theta plus ma sine theta? Or no, cosine. No, that shouldn't need, no. I don't know. 8 Ramsa, K. I have a test Friday. It's like entry-level trig and coordinate geometry will be the best way to study for this. I mean, it's just kind of practice with that. Like with pretty much everything in math, like all you can really do is just practice a bunch of problems. At least for the coordinate geometry piece, I don't have a good resource for. Yeah, the unit circle is big if you've gotten to that. So I really love this website for everything calculus, and they do have a little trig review section that you might find helpful. I'll drop the link once I get to the proper part. So like you could try, if you want some more things to like work on, you could try looking through this site. In the sidebar, it's algebra and trig review, and then trig, and then any of these that you might be interested in. You can have some like practice problems there. Yeah, Aiden, basically just a bunch of practice. AM, are you familiar with present worth and annuities? Oh, I haven't done them in a long time. Oh, forgot to mute. Sorry. If it's just like working with the formula, I bet I could do the question AM. If something more advanced, I probably can't. Uh, yeah, Rostislav, I see it. It's in a weird file format though. Let me see if I can. I have something that can open it. Steady creating control IRR. I haven't heard of those. I don't think. Ah, shoot. Okay, can I try opening with a different program? It seems like there might be an issue with the image file. Rostislav. I can't really open it. Can you try posting it again, maybe with a different format? Because the HEIC, I think, is like Apple's proprietary format. And even though it's telling me an error when I tried to open it. Yeah, I wasn't able to figure out how to open it. So I don't know if you can try to post it in a different format or something. Or, is there HEIC converter? Like a website that'll do this? Oh, I might have it. Okay. All right. In the future, please don't post that file format, but I figured out how to do it, at least for this time. Um, Critical, I'm sorry, but like, we, I did your one. Okay, so we're given that y prime is equal to xy squared, and we're asking, is y prime, or is y, I don't know why I'm copying it down when the question's right there. We want to investigate whether y equals 2 over 9 plus x squared is a solution. So how you do questions like this, like these are nice because you don't actually have to solve the differential equation. All you have to do is take their proposed solution and try to plug it in. Yeah, sure, Edison. So if we want to plug it into this equation up here, we do need to figure out what y prime is. So let's go ahead and take the derivative of this. Y prime should be, we have to do the power rule. So minus 2 over 9 plus x squared, and then chain rule times 2x. So clean it up a little bit, we get minus 4x over 9 plus x squared. All right. This is y prime, so let's plug it in to the differential equation. So y prime is equal to xy squared. So minus 4x over 9 plus x squared is equal to, now we have just the x, and then we take our original y and we square it. So that's our original y, 2 over 9 plus x squared. All right. And so we'll keep the left side the same. On the right, the top squares to 4, bring in the x, and the bottom I'll leave as 9 plus x squared. All right, so there's an issue here. In order for it to be a solution, these sides have to match exactly, and one is negative and the other isn't. So I'd say the answer to this question is no, because it just barely doesn't work because of the negative sign. Let me know if you have any questions on that, Rostislav. Then we'll work on Edison's next. Oh, okay. That won't be too bad. You got two different answers with USub and trig sub? Oh, okay. USub definitely seems like the way to go. All right, so if I do a USub, I'll do U is a squared minus r squared. du is minus 2r dr. So we're going to get minus a half a over root u du, right? I mean, the minus a half can go out front, and so can the a. Minus a half a. That u is going to integrate to 2 root u. No worries, Rostislav. So get minus a half a. The 2 times 1/2 is 1. So we get minus a root a squared minus r squared, evaluated from 0 to a cosine theta. Get minus a squared minus a squared cosine squared theta minus, well, plus a root a squared minus 0. Okay, minus a, we can factor an a squared out from the square root and multiply with that a, so we get a squared root 1 minus cosine squared theta. And then that becomes a squared over there. All right, so I'm going to bring this a squared in front. A squared minus a squared, and root 1 minus cosine squared is just sine. All right, so that's what I get the u subway. Or that's what I get for the u subway. The trig sub should be with sine or cosine, right? Yes, you agree? Good. Okay. So let's take the same integral and do it the other way. It should match. So if we take r equals a, let's just say sine theta. It hopefully shouldn't matter which one. A cosine theta d theta. Shahid. Oh, thank you so much for the kind words, Shahid. I wasn't saying that right. Yeah, that's very kind of you. Will do. A over root a squared minus a squared sine theta times a sine theta times a cosine theta d theta. Okay. Better job than politicians. I mean, I feel like it's a pretty low bar, but I'll take it. Won't complain. All right, so on the fraction here, the a's are going to cancel. In the 1 minus sine, oop, that's sine squared. The 1 minus sine squared becomes cosine squared, and the cosine squared gets square rooted. So we get 1 over cosine theta for that first bit, times a sine theta. This is bad, isn't it? Let's just keep it rolling. Well, Godspeed, Fembox. So we're just integrating sine, really, because the cosines cancel. So we're going to get minus cosine theta. I am being bad and using theta in two different senses. I have a theta here and a theta here, and those aren't the same thing. Oh, I think this will work out, because when we do this unsub, we're going to get a right triangle. So if r is equal to a sine theta, then theta is equal to arc sine r over a. So let's plug that in. a squared minus cosine arc sine r over a. And we do have to evaluate it from 0 to a cosine theta, but that'll be much easier if we simplify this cosine of arc sine thing. So I don't know if you've seen this before, Edison, but you need to draw a right triangle to simplify this. Right, that's the easiest way to simplify it. Why am I drawing like this? I never draw my right triangle like that. So if that's our angle there, arc sine is, or like sine goes with opposite over hypotenuse. So opposite is r, hypotenuse is a, and by Pythagorean theorem, the remaining side is a squared minus r squared. And so cosine of this thing is then adjacent divided by hypotenuse. So let's cross our fingies. So the minus sign is still there. The minus sign can go up front. And so cosine, I said, is root a squared minus r squared over a. We're dividing from 0 to a cosine theta. And we can get a partial cancellation with the a's. Root a squared minus r squared, 0 to a cosine theta, minus a. Okay, we're nearly home free. A squared minus a squared cosine squared theta, minus root a squared minus 0. Okay, please tell me this is going to match. A sine theta minus a. Oh, this looks good. We get a squared minus a squared sine theta. That matches, right? It does. Okay. So yeah, Edison, it should match. It is very easy to make a mistake on this. Where did I go? I'm not sure. I should have asked you which trig sub you did, Edison. Did you do the same trig sub that I did? Oh, you're right, Fembox. You could make that a squared cosine squared. Yeah. No, you'd have a square root. This sign is not squared. Or, no, never mind. That just doesn't work. It's just signed to the 1 there. R equals a sine u. Okay, yeah, so we did do the same sub. So hopefully, like, you should be able to compare with my work and see hopefully where we start having different things. Or if you're in the Discord, like, you can post your work and I'll like take a look at it. But yeah, it should match regardless of technique. And we'll scroll away from this, so if you want to screenshot, then be sure to take one. Yeah, sure. Until I see, I'm going to go back to doing this studying here. All right, so I was looking at 14 before, and this is an annoying question. So I can't figure out how the normal force is working here. Okay, so it's like, hey, Sir No Enjoyer. So like this overall net acceleration to the right is like trying to push the block up the plane. Like, if it's accelerating to the right, then the block should be getting like pushed in that direction back, and that's what normal force is supposed to balance out, I guess. Oh, I guess that's how. Is that all I needed to know? um is it that mg cosine theta equals n? Is it also cosine theta? Maybe it is just mg. I would really hate that. But honestly, that kind of makes sense. Because it's saying still. Actually, okay, yeah, I think it's A. I think I've convinced myself. Like, the normal force has to account for the entire weight of the block. I hope I didn't... By setting up this equation and canceling the cosines. So, when I was doing this problem, I was debating between these two because they have asymptotic behavior at potentially convenient places that should have like a weird behavior that's undefined. But like neither of them seemed to work perfectly, and so I was just kind of going back to the drawing board, and I managed to convince myself of this. I'm thinking that in order for the block to stay still, the normal force needs to balance the component of gravity parallel to the plane. And if a normal force points up like that, and that's theta, oh, I don't know anything about relativity yet, Sen. Hey. That's not, at least not the intention to use any relativity here of this problem. Sir No Enjoyer, how do you find legs A and B in a right triangle if you only have the hypotenuse, and is it possible? if you only have the hypotenuse, it is not possible. You need to know an angle. Like you need another piece of information about the triangle. Because if you have that same hypotenuse, I could draw a right triangle like that, or take the same hypotenuse and I could also draw a right triangle like that. So you just don't have enough information to distinguish. Tell me the hypotenuse height. Yeah, legs are between 0 and 10. Exactly. There's constraints, but you don't know exactly what the legs, like the legs don't have to be one thing. Okay, Fenlux is making me doubt this MG line of thought. Thank you, thank you. As also that if the block is at rest with respect to this plane, it kind of makes sense to me that the normal force should be offsetting the entire MG kind of weight of the block. Like, I feel like this is analogous. Like, it shouldn't be offsetting a portion. Like, maybe it's more than the weight. I don't know. Oh, yeah, if both angles are 45, you can definitely do that then. So if you have a right triangle, and both of these angles are 45 degrees, I'll make up a problem and say that the hypotenuse is 5. So there's two different ways you can do this. I'm assuming you don't know trigonometry. Like if you haven't heard of sine or cosine or tangent, you could do it with those, but I'm assuming that you're not familiar with those, so I'm not going to use those. You don't? Okay. No worries. So the way they can do it without that is, this is an isosceles triangle. Because an isosceles triangle, if you have two of the same angles, that means it's isosceles. So we know that that side and that side also should be the same length, because it's isosceles. And so an isosceles right triangle is definitely a thing. And so now this next part, it might depend on how you're being taught it. Do you know the Pythagorean formula a squared plus b squared equals c squared? Does that look familiar to you? Yes? Okay, perfect. So here, c is the hypotenuse. So in the example I made up, that's 5. So actually, I'm not going to write the a or b yet. On the right side, we'll have a 5 squared. Yeah, exactly. We can call these other two sides that are the same x. So we'll get x squared plus x squared is equal to 5 squared. And so x squared plus x squared is 2x squared equals 5 squared. Exactly, yes. That's perfect, Cerno. And now we just solve this for x. So I'll divide each side by 2 to get x squared equals 5 squared is 25 over 2. And now we take the square root of each side. So we get 5 divided by root 2. And technically, depending on your teacher, you do a plus or minus whenever you take the square root of each side. But this is a geometry problem and negatives don't make sense. If your teacher is really picky, you might be supposed to have a plus or minus there, at least for a step. But usually you don't worry about it in this context. Um, one thing that you almost always have to worry about is having a square root in the denominator. There's nothing actually wrong with it, but for whatever reason, like they just want you to not have the square root in the denominator. And you can do that by doing what's called rationalizing the denominator. We can multiply this fraction by root 2 over root 2. And so like this is just a fancy 1, and you're always allowed to multiply by 1. And the magic of this is on the top we get 5 root 2. Oops. And on the bottom, root 2 times root 2 is just 2. So I'd say that is the lengths of each of the sides. Like each of these sides individually is 5 root 2 over 2. Math snobs like to rationalize a denominator? I guess so, yeah. No worries, sir, no. Thank you for the question. All right, we might wrap up. I want to figure out 14, and then we might wrap things up. Got a little I voted sticker. I think I threw mine away. I'm gonna be honest. Ducky3, thank you for the follow. Yeah, have a good night, sir. No, thank you for the kind words. Yeah, no, I mailed my ballot in like a couple weeks ago now. A new, if only $10. You know, next election I'm gonna go door to door asking people to sign my petition to make a new California Republic. Okay, maybe is it actually that mg cosine theta equals a in magnitude? Does that mean the normal force is just mg cosine theta? That'd be lame. I don't like that. I don't know, man. I don't think I can eliminate any of the answers right now. I feel like I've lost progress, if anything. Like, I still feel like there should be some asymptotic behavior, which would indicate C and E, but neither of them feel like they're asymptotic in all the right places. Like, this is asymptotic in the horizontal case, but not the vertical in the reverse for cosine theta. And if I feel like it should be asymptotic in both cases, because the block otherwise can't remain in the same position. But maybe, can we just find our way around that again? Like, what happens as theta gets close to 0, but not exactly 0? The normal force would really need to blow up, right? Which would indicate sine theta. And as theta goes to 90, it doesn't need to be very high at all. That's my instinct. I might just send C and see what the book says. I want to actually solve it via some algebraic method like that, but I don't know how. I can't figure it out. So I don't know. I might have to set up this limiting cases argument. Let's just send C. Uh-oh. It's E. I didn't do the cases right, I guess. The vertical component of the normal force must equal mg. Oh. Damn. Oh, did I just mess up? No? Okay, I don't know. I was just doing the limiting case backwards, I guess. Okay. Um, yeah, that's such a quick way of doing it. I was focusing only on the other component. I didn't realize that you could just immediately get the answer from the vertical component. All right, I think we're gonna wrap things up though. Um, so yeah, anyone, what the hell? Oh, I see what's happening. Anyone's here on YouTube, thanks for being here. This is actually my last YouTube stream for a couple weeks because I'm going on vacation. So I'll be doing DayZ tomorrow, Pinbox. That's what I'm planning, and then I'm gone. So yeah, anyone who's here on YouTube, thanks for being here, and I'll be back on YouTube in a few weeks.